Bismillahirrahmanirrahim. Assalamu alaikum. Let's start chapter 10 of D2. And this chapter is about Pythagoras Theorem. And the Pythagoras Theorems gives us the relationship between the sides of a right angle triangle. When we say a right angle triangle, it means a triangle which has one angle equal to 90 degree. So whatever we will be dealing with, we're going to have a triangle, problem which is making a triangle, one angle has to be 90 degree, and if the one angle is 90 degree, we can easily apply this Pythagoras theorem. So let's draw one triangle having 90 degree angle, and we'll talk about this relationship. Okay, so let's say this is our triangle. One angle is 90 degree angle. Okay, and the side opposite to the 90 degree angle is known as hypotenuse. Now I have a 90 degree angle over here. Other than this 90 degree, there are two more angles. One angle is here. Okay, let's say this is angle A. Now the side opposite to this angle A is known as perpendicular. Side opposite to angle A. Now this angle has two adjacent sides, this side and this side. This side is already named, this is hypotenuse, and this side, remaining side, is known as base. Now this theorem says that I'm going to give you a relationship, and what that relationship is, that this side, which is known as hypotenuse, this is the square of this hypotenuse is equal to square of perpendicular and base. Square of hypotenuse is equal to square of perpendicular plus square of base. So hypotenuse square is equal to perpendicular square plus base square. Okay, so square of hypotenuse is equal to sum of square of perpendicular and base. Now let's do an example to prove this is correct. Okay, let's do an example. Okay, I have a triangle ABC. The base of the triangle is 3 centimeters, perpendicular is 4 centimeters, and the hypotenuse is 5 centimeters. Now this is freehand drawing. I haven't measured any side, but what I am saying is, suppose that the base is 3 centimeters, perpendicular is 4 centimeters, and the hypotenuse is 5 centimeters. Now I am going to use perpendicular and base, and I am going to prove that it is equal to 5 centimeters. Okay. So what this relationship says, hypotenuse. What is hypotenuse here? BC. So BC square is equal to perpendicular square, which is AC square, plus base, which is AB square. Now let's put the values of perpendicular and base. I'm not going to put the value of hypotenuse. I'm going to calculate it. Okay, so this is 4 square plus 3 square, which is 16, plus 9, which is 25. So BC square is equal to 25, and the BC is equal to 25 under root, and which is 5. So proved. The relationship is correct, and when we say that the hypotenuse square is equal to the sum of square of perpendicular and base, we can safely say it is correct. Let's do one more example of this relationship. Okay. Okay, I have another triangle. And if we see in this triangle, I have a 90 degree on B. So this AC side becomes hypotenuse, and we have angle here also. So this is perpendicular and this is base. The perpendicular is not known, we have to find it. So let's apply this relationship, hypotenuse square. So it is AC square is equal to perpendicular square, which is BC square, plus base square, which is AB. Now AC, what is it? 20. BC is not known, plus AB which is 5 square. So BC square is equal to 400 minus 25, which is equal to 375. Now BC is equal to 375 under root. Apply calculator over here, and it is approximately equal to 19.4. So this is 19.4 centimeters. Okay, so now you got the idea of a basic relationship of this Pythagoras theorem, that the square of the hypotenuse is equal to the sum of square of perpendicular and base. If any of the side is not known, we can apply this relationship and we can find it out. Okay, now let's do some couple of more examples which are bit difficult. So let's do those examples. Okay. Okay, now I have a triangle and triangle within a triangle. So there is one triangle ABC and there is one triangle ABD. This triangle ABC is actually within ABD, right? This BC, what this dash means, this BC is equal to CD. Okay, now I have to find BC and CD. Okay, if I want to find CD directly, I cannot find it, because this triangle ACD, it's not a right angle triangle. So I cannot apply this relationship on this ACD. No, I cannot apply. So what do I do now? So this ABC, this is right angle triangle. Okay, so I can apply here this Pythagoras theorem, and if I am able to find BC. Now this BC is equal to CD. I find BC, CD will be the same. Okay, so this hypotenuse square, which is AC square, is equal to perpendicular square, which is AB, plus BC square. Now this is 4 square, 5 square. This is 4 square plus BC square, and which is 25 is equal to 16 plus BC square. So BC square is equal to 25 minus 16 is 9. So BC is equal to 3. So this is 3 centimeters. Since this is equal to this, so this is also 3 centimeters. Okay. So the purpose of this example was that if you have a triangle like this, there is a triangle joined to another triangle or triangle within a triangle. So you have to look for a right angle triangle. Once you find the sides of a right angle triangle, then you can see if is there any relationship. Of course there was a relationship that this side is equal to this side. This BC is equal to CD. So we said, okay, this BC is 3 centimeters, CD is also 3 centimeters. Now we have both the sides. Okay. Now if we want to find AD, now what we have to do? We will consider triangle ABD. This is right angle, right? So this is 3 plus 3 is 6, this is 4, and we can find this AD easily. Okay, one more example. Okay. Okay, now I have a playing field. This is a playing field, okay? Playing field. Now, this playing field has to be fenced. We need a measurements of the boundaries of this playing field. Now, what we know is that the length of the rectangle is, this is also a rectangular shape, so length of the rectangle is x plus 7 meters, breadth of the rectangle is x meters, and the diagonal is x plus 9 centimeters. So we have to find the sides of the rectangle, so we can say that okay, this each side of the rectangle is this much. So what are we going to do? So how to solve? So since we know that rectangle has 90-degree angles, every corner of the rectangle is 90 degree. So it's a rectangle, so this is a corner, this is 90 degree. Okay, this is also 90 degree, this is also 90 degree, this is also 90 degree. Okay, now if this is 90 degree, so we will consider only this part. Okay, we say that P, Q and R. So this PQR is the area of interest. So this QR is opposite to right angle triangle. So this is hypotenuse. Angle is here also. So this is perpendicular and this is base. Okay. So hypotenuse, which is x plus 9 square, is equal to x plus 7 square plus base, which is x square. So now remember, we have done identities, a plus b whole square. So x square, I'm not going to give you the detail here, I'm just going to apply here, plus 18x plus 81 is equal to x square plus 14x plus 49 plus x square. Okay, identity is applied. Okay, now let's simplify this equation. Okay, x square, right? So I'll take this side, this left hand side towards the right hand side. Okay, so I'll be left with x square. This goes over there, minus 18 plus 14, so gives me minus 4x. Then this minus 81 and plus 49 gives me minus 32 is equal to 0. So okay, I have here a quadratic equation, and how we used to solve these? By midterm breaking. Okay, let's apply that. We can apply a quadratic formula also, but right now I'm going to apply midterm breaking. So 1 into 32 is 32. So I need a factors which gives me minus 32 and minus 4. So if I have x square minus 8x plus 4x minus 32, these are my factors. Minus 8 into 4, minus 32. Minus 8 plus 4, minus 4. Okay. So x into x minus 8 plus 4 into x minus 8 is equal to 0. So x minus 8, x plus 4 equal to 0. So x is equal to 8 and x is equal to minus 4. Since I am interested in the sides of a plane field, I'm not going to take negative side. Okay, I'm not going to take this, I'm going to take this. So it means that the breadth of this plane field is 8 meters, the length is 8 plus 7 is 15 meters, and this diagonal, if I am interested in this, so it is 17 meters. So I have this So if it has to be fenced, it is 15 plus 15 is 30 and 8 plus 8 is 16, so 46 meters altogether. Okay, this was all about Pythagoras theorem. Hope you got the idea. Thank you very much. Next time we'll start another new chapter. Thank you.